Hello everyone, this is Ms. Burr, and this time we will be going over the 1-1 States of Matter notes from Unit 1. So the guiding question for this section of our learning is, what are the three states of matter, and explain how they differ from each other at the particle level using models as needed. The do now is also completed in your guiding notes. So using 6 circles represent the particles, 6 particles for each model. Draw a model of ice, liquid water, and gaseous water or water vapor, thus creating 3 separate models. And you'll do that in your notes. So on to our notes. The 3 states of matter that we will be studying this year are solids, liquids, and gases. There are other states of matter too, such as plasma and Bose-Einstein condensate. Solids are materials that have a definite shape and volume. They cannot be compressed because the particles are very close together, often in a regular arrangement. The particles in a solid are close together because they have strong attractions for each other. These attractions are called intermolecular forces, or IMFs. The strong IMFs found in solids mean that the particles move very little. They generally only have vibrational motion. Liquids have the ability to take shape of a container, but they have a fixed volume. The particles in a liquid are generally slightly further apart than in a solid, but because the particles are still very close together, they cannot be compressed. Liquids usually have weaker attractive forces than solids, and thus they can vibrate like a solid, but they also can slide past each other. This sliding past each other is called translational motion. Gases will take the shape and the volume of the container that they are placed in. The particles of a gas are very far apart compared with the size of the particles themselves. This means that gases are very compressible. The gas particles are in constant random motion, moving in straight lines until they collide with each other or the walls of the container, wherein they will bounce and change direction. Gases have vibrational, translational, and rotational energy. So vibrational energy that's present in solids, liquids, and gases is like when you sit in your seat at a table or at your desk and you fidget. You're staying in one place, but you still have some motion. Translational energy is when you get up and walk across the room. You're still contained in an area, and you can't like flail all over, and sometimes you still fidget if you're standing or walking. And then rotational energy is if we were to have you guys or children or like young children and release you out onto the field, you might, in a fit of energy, run and spin around, rotating as you go. Small children would also do this. If you release them onto the field, they're going to run around like crazy, kind of fidget sometimes, and spin around like crazy people, because that is the joy of being a child. So when one state of matter changes into another, these are called phase changes. Phase changes are considered physical changes because the material chemically stays the same. For example, when liquid water freezes or evaporates, it still remains the same chemical substance, H2O. The only things that have changed are the arrangement of the particles and the amount of energy in the substance. The energy that particles have due to their motion is called kinetic energy. Temperature is the way that we measure the average kinetic energy of all the particles in a substance. Another way to change the state of matter is to add or remove pressure. So in a gas barbecue tank, we have liquid propane. When the valve is opened, the pressure is decreased, and liquid propane will then be able to turn into gaseous propane, which is easily able to ignite and cook your food. So here we are at the I do's. So together we will do these. So if a substance fills a container, it is incompletely and takes the shape of the container. What state of matter is the substance? Well, looking at takes the shape, that takes the shape can either be a liquid or a gas. So we have to look at the other one. Fills the container. Well, there's only one state of matter that fills the container, and that is a gas. So saying that gas has both of these necessary characteristics, the state of matter is a gas. What is the name of a phase change from a gas to a solid? So we would go back into our notes to this, and we see we want to change from a gas into a solid. So this is deposition. Is when a substance changes from a gas to a solid. Now, seeing our question 3, what phase is the state of matter? What phase of matter is shown in the image? So looking at it, we see it's got a fixed volume. It fits all in here. It doesn't fill the container. It's in that one spot, and it also has a fixed shape. So fixed volume, fixed shape. We also see that it has a regular pattern. These are all characteristics of a solid, if we look back at the beginning of our solid summary. Okay, so the we do question, you will see in your notes that there is a QR code available to you. You will scan the QR code and complete that alongside the video that is in the QR code. When you are all done, make sure you complete the you do in your notes packet. If you are absent, you can either upload your work to the Schoology assignment or hold on to it until you return to class. Please do not forget that at the end, when you are finished with everything, that you answer the guiding question in the space provided at the end of the notes in your notes packet. Thank you, everyone.